Hello students and YouTube learners. This is Dr. Satish Singhal, PhD, Professor of Computer Science at Camino College, Torrance, California. I'm here with C++ arrays video number 4, and in this one we'll discuss arrays and their members being passed to function as arguments. As you know, for modularization, passing data to function is extremely important, and in this video we're going to see how that is done for array members passed one at a time to the function as an argument, and then entire array passed to the function as an argument. And basically it is possible to pass an array or only one or more of its members from one function to another to process them, and we'll be covering these topics. Topic 1, passing one member of an array at a time to a function. Topic 2, passing entire array to a function. We're going to discuss the passing mechanism through a code on Xcode. And third will be passing an array of integer to a function and finding average of all the numbers in the array. So that's like one example of data processing. Chapter 10 of the ebook, single ebook, has a lot of other examples which you can read and refer to. And topic number 4 will be function mutating or altering an array passed to it. And finally, allowing read-only access to the array when passed to a function, or passing array to a function as a const object. We have learned in functions that you can pass single variable as a const object so that it's not altered by the function. We can do that for array as well. So let's get started with those 5 topics one at a time. So topic number 1 is passing one member of an array to a function at a time. So if the selected element of array are passed to the function, they behave just like atomic variables being passed to the function. And here we show how we can pass each individual element of an array to a function called print square, and this function prints each member of the array. So let's look at this picture here. Hopefully I can get all of it in one screen. Yeah, actually I did. So this is our program. Let's look at the program, and through pictures we'll see how we can interpret this program. So we have a function void print underscore square int x. So notice here, whether we pass one element of the array, integer array, to the function or any other integer, function prototype does not care what you pass to it. So there's no effect of one element of array being passed to the prototype of this function, print square. And let's look at the definition of print square. So all it does, it gets a integer as an argument by value. That means calling block will copy the value into x, and then we simply do x into x and print it out onto the computer screen right here. Okay, but since we are passing an array, story is a little bit different. So here we declare an array called base. It has 5 elements, 5 members, 3, 7, 2, 4, 5. So our array will look like this. First element 3, second 7, 2, 4, and 5. And since array name is base, first element will be base 0, second base square bracket 1, third base square bracket 2, fourth base square bracket 3, fifth base square bracket 4. Now when we are passing only, now let's look at the for loop actually. So for loop runs 5 times, 0 to less than 5, and each time it's calling the print square function, and notice what it is passing to the function: base square bracket I. So when I is 0, I'm passing to the print square function base square I 0. So what is in base square 0 is 3. So 3 gets copied into X, and then we output 3 into 3, that is 9. So that's how the first one is printed. Then second one, then we get back to our for loop. So then I becomes I plus plus, I becomes 1, and this time we are calling print square with base 1, and you can see base 1 is 7, and then 7 is copied into X, and we print 7 into 7, that's 49. Okay, then we have 2, and base 2 is 2, and then base 2 is 2, and then we copy that into here, and 2 into 2 is 4, so we print 4, and then same way we print 16 and 25. Okay, now notice one very important thing. When we are passing only one member of the array to the function, we take the array name, square bracket, and an index of that element. So function call changes that way when we are passing only one member of the array to the function. So this is very important because when we pass the whole array, the syntax is quite different. And this is actually logical because we have told you already many times that if you want to identify one member of the array as an individual variable, you take the array name, square bracket, and you put inside that you put the index of that array member or of that array element. So copy of this document will be available to you, and you can pause the video right now and just view this more carefully, or you can rewind it and hear my words again. But it's very important that you understand the whole mechanism here. Okay, all right. So in this example, we are passing each individual element of an array to a function called print square, which prints the square of each element passed to it. The function print square does not differentiate between an array element and a single atomic data as long as data type is same. You can see that from the prototype here, header, that whether you pass 5 to the print square or member of an array, is just going to take square of that and print it. So it's really as simple as that. Alright, so let's go to our next topic, topic number 2, which is passing entire array as an argument to a function. When an array is passed as an argument to a function, following things are required. Generally, functions that work with an array require 2 items of information as arguments. Beginning memory address of the array, base address, that is simply an array name. We're going to verify for that for you in a minute. And the number of elements I would like to process. If I want to process all the elements, an array length has been declared as a global constant, then function does not need an argument for that. But if I want to process different number of elements, then I'm going to need a logical length. So items sent to the function to process array are name of array and its logical length. Passing logical length can be omitted if it is equal to physical length and if latter is declared globally as a constant. And it is important to realize that when arrays are passed to the function, they are automatically passed by reference. No ampersand symbol is needed, and we are going to prove that in a program very soon. And we demo that in our compiler Xcode, where we pass an array to print function and we print all of its members to the console. So we're going to go to Xcode now. So let's see the whole program. Maybe we can't see the whole program, but that's okay. We'll work with this. Okay, so I have you're familiar with this program I did, a number table program, um, in the one of the earlier array videos. So what I'm doing here is I'm declaring a number table array of size 10, max is 10. Initially it has not zeros in it, and then I create a number table of 2 and store in this array. So it will be like 2, 4, 6, 8, 10, 12, etc. And then in previous video I had printed with a for loop here, but this time I want to do it by passing array to a print function. So as I said, we need two elements, two arguments to the function that takes array as an argument, and we are doing that here. We have the array itself and the length of the array that we want to print. Now notice this syntax here, very crucial syntax. You're used to up to here if you're passing a single element. But when you're passing array as an argument to a function, you tack on this square bracket. That's how function header changes when you're passing an array to a function. Meaning of this is that, hey, the name here is an array. Now, generally you could rewrite this by leaving the names out like this. As a function prototype, that's definitely acceptable. But line 7 is preferred because when we write documentation on this function, we are going to need the name. But language will accept that also. As you know that compiler ignores the names, it only looks at the data type, and in this case it will know that it's an array. So this or that is, both are okay, but in professional setting this is preferred because we need the names of the variable to do any documentation. So in CS1 we will not follow this method, we'll always have names of the argument. Okay, so what is the meaning of that? Meaning of that is I'm passing this function, first argument is an array of integers, second is the length that I need to process. So let's look at the full definition of this print function, and that's right here. So we're going to worry about this a little bit later. Okay. We're just going to print the array elements. So I'm getting the table array and I'm running a for loop from 0 to, actually I can do len here, yeah, 0 to len and index plus plus. So we have shown this before. Basically this for loop will print this array that came. Okay, and again I'm going to do this in a minute. So just comment that out for now. So let's look at this one first, only this one, and let's see address. Okay, I'm going to do this also a little later. Okay, so let's look at this condensed program first. This for loop will create a table of number 2, 2 2 2, 1 2, 2 2 2, 2 3 2 2 4, 2 3 6, and so on. Okay, and then I'm calling the print function to print this array. Notice the syntax. I do not have a square bracket when I'm passing the array. If I was passing only one element of the array, then I'm going to have it. So this is, you have to be very careful about this syntactic sugar In computer science, people say, "Ah, syntactic sugar." No, it's very important. You have to get the syntax right. Take some practice, but once you get it, it's not a problem. So then this array, the first element has an address. That address is exactly address. In fact, you're just copying only the address of the first element. And then it prints here. And addresses are same. We'll show that to you in a minute. But let's just look at this program first, and then we'll explain it to you. Okay? So let's just run this one as it is. So printing array elements now, 2, 4, 6, 8, 10, 12, 20. So what happened was this loop filled the number table with the table of number 2. Then I call the print function. Print function runs this for loop and prints it. So the question is, how is it that this and this and this are same thing? Okay, so we can actually just print the address of the first element. So let's do that. So printing address stored in the array name number table. When I do this, just the name number table. One characteristics array have is that name of the array contains address of the first element. In fact, I'm printing the address with name, and I can print the address with the first address of the first element also. So let me just add a little bit of code here. You'll see they're exactly same thing. Okay, array element number table 0. Okay, and I'll do that. This time I have to put the ampersand sign because now I'm dealing with one element. Okay, so if this address and this address came out to be the same, we can confidently say that name of the array stores address of the first element. All right, and then we want to prove that arrays are automatically passed by reference. So when I'm passing this address, which I'm printing right here, then here if I print address stored in this name, that should come out to be same as this one and this one. So let's code this one in as well. Okay, so you'll see something very interesting this time, and nicely enough, first we'll print 3 addresses. No, okay, so I'm gonna comment this. No, that I have to do, otherwise I won't be able to print the address. Okay, so let's see. I don't want to interfere with numbers. Okay, that should be okay. I think everything will be fine. Yeah. So basically, when we run this for loop will fill number table of 2 into this array. Will print address stored in the array name number table right here. Notice I'm not using ampersand here because I'm just using array name, and array name stores address of the first element. But then I'm using ampersand with the first element of the array. That means now I'm printing the address of the first element itself. Okay, so as I said, if this address stored in this name, they should print the same thing. And then I'm printing address stored in this name table, and so this and this should give me the same thing. So first 3 lines of this output should give me exact same number. Let's see if that happens. All right, so this line printing address stored in array name number table. Notice name number table is, and I'm just not going to bother with all the digits. Let's just take last 4 digits, 5408. You can pause the video and look at all the digits, but I'm just going to focus on that. And then the second line, printing address stored in array element number table 0, exactly same thing. And then it got passed in this function call to print function. That means this array and this array are the same thing. And then we are printing name addresses stored in name table here, and you can see that is the same thing as well. Hold on a second. No, I messed it up. Okay. Yeah, I kind of moved it, but it's the same thing. Okay. So that proves that when you pass array to a function the way we did here, the address of the first element is passed, because this address turned out to be the same as address stored in the first element or addresses stored in the array name. And once we have the address of the first element, then this square bracket syntax allows us access to each element, in this case of course sequential access. Now you can say, okay, can I print address of all the elements? Sure you can, and let me show you that. So let me comment in this code here, and you can do that in the main function or here, that won't make any difference. So printing address of each array element, I'm just doing this. I'm running this for loop, and I'm taking one element of the array at a time, and ampersand sign means that I'm printing its address. So when I run this code again, you will see that after printing array elements, you will see addresses of each element. Of course, first address will be same here, same here, same here, and same here. But then at a 4-byte gap, you will get address of all the other 10 array elements as well. Okay. So this is a lot. This program will be given to you also, which you should compile and run for full understanding. You will not be able to understand fully just by this video. This video is just giving you foundation. You'll get a copy of this program, and you'll have to run it for yourself and view all the elements of this program that I've discussed in the video. Okay, so let's do the whole program now. Okay. So remember, we were printing address stored in the first element of the array two different ways. Address stored in name number table and address stored in number table first element, and they are the same. You can check that these two numbers are same. Then in print function, I print through this statement address stored in name table, and that turns out to be the same also. So that means this proves beyond any doubt that arrays are automatically passed by reference. Ampersand sign is not needed, but after the array name you do need this square bracket. That is the order to the compiler or computer that pass the memory block that array is its first address of the first element, and from there the square bracket index does the iteration through rest of them. Okay, so then we print the table of number 2 right here. But now the interesting thing, I'm printing address of every element of the array. So first address should be this, and that's exactly this one here. Okay, let me move this up. You can see this number and this number is same. Okay, and then in the second loop iteration, index will become 1, then I'm printing the address of the second element or index 1 element, and that should be 4 byte more. So you can add 4 to it, you'll get 12. And then the third element 16, fourth element 20, fifth 24, and so on. Okay, until the last element 44. All right. So we have proven many things. That most important is that when arrays are passed to a function, once you put the square bracket there, that means arrays are automatically passed by reference. An entire memory block is accessible just by getting the address of the first element of the array. So this is a mouthful, this is a lot. Very important thing for you to do after watching this video will be, this program will be available to you. You actually compile and run it and view it and view every printout from there, every output, and see how we have proven what we just said, that arrays are automatically passed by reference as long as the passing syntax matches data type, array name, and a square bracket. Okay, so we are done with this. We're back from Xcode, and now we're going to go to our topic 3. Topic 3 is passing an array of an integer to a function and finding average of all the numbers in the array. So here we show a process of finding an average. So we do something very simple. We have a function called average. It returns a double type and takes an array of integer as an argument. And we're just going to assume that we have a length declared globally, so we don't have to pass that. So we have a variable called AVE, unpopulated. Then we have an array of 5 elements, 3, 7, 2, 4, 5. So this array will look like this. Name is base. So base 0 is 3, base 1 is 7, base 2 is 2, base 3 is 4, and base 4 is 5. And average function takes an array of integer as an argument. So here's our function call on the right hand side. As soon as this function call is made, control is transferred to the average function. That means this address is copied into the X. Because we have square bracket here, order to the computer is that whatever address is stored here should be copied here. Notice once again there is no square bracket here. When you're passing the entire array, you don't put square bracket. You just use it just like an ordinary, just the way you pass ordinary variable. And this is very confusing to some of the students, that how behavior can be same, but trust me, that's how it is. Okay, so now what do we need to do? Find average. We need to sum up all these, and we know it's 5, and divide by 5.0 to get the average. So since this entire array got passed into X, in first iteration I is 0, I less than 5 is true. My sum was set to 0. Sum plus equals xi. Then the first time my sum will be 3. Okay. Then I becomes 1. 1 less than 5 is true. Second time I'll add 7 to the 3. Then 2 to the 10, 12, 4, 12 and 4 is 16, and 5 is 21, and 21 divided by 5 will be returned, and once again you'll have to type this program to get the answer. But that's the whole idea, that this address is stored into X, and then X can give us access to all the other elements through xi. Alright, so source code for this is not given as a text, but you can look at the screen, pause the screen, and this is again in the ebook also, and you should actually type this program and run it. Now, important thing is pay attention to the syntax of function prototype versus function call. Function prototype uses the square bracket. Function call does not. Students get very confused by this, that how can function prototype a square bracket but not the function call. But that's the way it is, because you're passing content stored in this name, that is the address of the first element of the array, and that gets copied here. So you don't need a square bracket here actually. Function prototype has the data type as well as square bracket to indicate. Then an array of data type will be passed to the function. Although in this figure you can write function prototype either this way or this way, they're both the same, and I showed that to you in the Xcode as well. So function header is exactly the way we have done here, like this, and then function body. But prototype could be either this way or that way. But as I said, industry standard is write it this way because variable name is needed for documentation. Alright, so we have finished the topic. Okay, and as I said before, you only need to pass name of the array. If you do this, that will be a syntax error, compile error actually. So that's just a little bit more emphasis on that. Okay, so finally, or is it finally? No. Topic 4. We can use function to mutate or alter an array passed to it. So what is the meaning of that? When an array is passed to a function, then basically the address of its base element or address of its first element is passed. First element is called base element. The function can access all other elements because it has the address of the base element. This gives function actually capability to change the value of array elements. This we are showing here, where we are passing the array to a function called multiply2. It actually multiplies each array members by 2, and since it got changed and arrays are automatically passed by reference, it will come back to the calling block in changed state. Okay, so let's first look at, and this is a little bit off here, but we can make it a little better. So look at the prototype first. I have function multiply2. That's taking an array of integer as an argument. And let's look at the code inside it. What it does is just runs a for loop. There are 5 elements. So we run for loop on all 5 elements. And we are multiplying each array element by 2. That's all we're doing actually. And then we're not printing it here, but we are just showing you what change will be there. You can put a for loop here to print it, not a problem. But we are explaining whole process here in the picture. So I declare an array called base, 5 elements, 3, 7, 2, 4, 5. My array is going to look before passing to the multiply2 function, 3, 7, 2, 4, 5. This is base 0, base 1, base 2, base 3, and base 4. Then I'm passing the array to the function, and address of the first element gets copied on the S, and then I'm running the for loop. So first time I is 0, that is base 0. When this code runs, immediately in real time, like a live wire, base 0 changes to 6. It's very important to realize that the array called base and array called X are the same thing. And as soon as it changes to 6 here, it changes to 6 in this location as well. Then I becomes 1. 1 less than 5 is true. I take x2 multiplied by 2, which was 7, becomes 14. as soon as it becomes 14 here, it's going to become 14 here too, in real time. So this process keeps happening in the real time. 2 becomes 4, it's going to change to 4 here as well. Becomes 8, becomes 8, 10, 10. And if I print the array base after call to multiply to function, it will be exactly these numbers. So I will recommend that you type this code and put a for loop after multiply to function call, and you will see that the whole array has gotten changed by multiplication factor of 2, 6, 14, 4, 8, and 10. So all these things that I'm telling you to do, please do them. And effectively arrays change in the main function as well, and each element is multiplied by 2. So this repeats the same principle that we said before, that in passing array to a function, if function changes it, entire array is changed in the calling block as well. Okay? Because arrays are automatically passed by reference, no ampersand sign needed. Okay, now I'm getting to the last topic, topic 5. Sometime we want to pass array to the function, but we don't want to mutate it. Maybe we just want to print it. And you know, from the chapter on functions, we could use the word const to disallow calling block making any changes even though we are passing it by reference. You could do that with the array as well. So allowing read-only access to the array members when passed to a function, or passing array as const object. Keyword const must be used before the formal argument in the function prototype and body header if array should not be changed by the function to which it is passed. For example, code given below will cause compile error because array is passed to the function multiplied to as const, and because function tries to change the value of its elements. Okay, so we have the same listing as we before, but this time I put a const in here. Okay, and then I have the array, same array base, 5 elements, 3, 7, 2, 4, 5. I pass it to multiply 2, pass the array to it, but this time I have word const here. So as soon as I try to do this multiplication by 2, I'll get a compile error because I put the word const here. You can't change the array if that is the case. So this is an example in negative, more or less, that you can do it. And why are we using multiply 2 if we don't want to change it? Better example would be the print function that I did in the Xcode. I can show it to you. So here, print can accidentally change the array, and if I don't want it to be changed by the array, I'll put the word const here and the word const here. Okay, and of course all print does, it prints it. So in this program here, I'm not going to see any difference if I put the word const here and the word const here. But in multiply 2, if I put the word const here and I try to multiply each array element by 2, I'll get the compile error. Okay. So to make arrays immutable, one can pass them at const object, just the way we can pass single variables as const objects. But of course, it should be done only in the case when you just want to print the array. You don't want to change anything to it. All right. So those are 5 of our topics in video number 4 on arrays. And thank you and goodbye. I'll see you in the next array topic, where I just want some general properties of the array to be discussed and how to fill arrays. And print arrays by function we have already done, but I just want to show you how you can fill the array by function and some of the other aggregate and non-aggregate properties of the arrays. Thank you so much.